of diabetic nephropathy involves hypertension and hyperglycemia-induced changes in multiple pathways that contribute to morphological changes in the kidneys. The glomerulus is a globular-shaped structure composed of capillaries that are actively involved in the filtration of fluid from the blood to form urine. With diabetic nephropathy, early glomerular hemodynamic changes include hyperfiltration and hyperperfusion, which result to microalbuminuria. Increase in afferent arterial dilation due to dysfunction and vasoconstrictive autoregulatory response contributes to increased intraglomerular pressure, which is associated with greater mesangial cell matrix production. Expansion of the mesangial area, an early morphological change with diabetic nephropathy, is caused by greater extracellular matrix deposition and mesangial cell hypertrophy. This expansion is associated with decreased glomerular filtration rate and reduction in the surface area for filtration, which marks the beginning of renal failure. As this process continues, the glomerular basement membrane thickens, and this may eventually lead to glomerulosclerosis. All of these changes in the glomerular hemodynamics cause stress and strain in the kidneys, which, if left untreated, may result to end renal failure. As of March 2013, World Health Organization states that there are 347 million people who are diabetics and that it will be the 7th leading cause of death in the year 2030. About 80% of deaths related to diabetes arise in low and middle income countries, including the Philippines. Synthetic drugs are associated with adverse reaction. The flavonoids have been proven to have antioxidant, anti-allergic, anti-inflammatory, antimicrobial, and anti-cancer activities. Sibuyas Tagalog, a native and abundant species of onion in the Philippines, have been found to have these flavonoids. Thus, this led researchers to the determination of the renoprotective property of the flavonoids of Sibuyas Tagalog bulb, Aleucepa, group aggregatum, family Aliaceae on streptozotocin-induced diabetic nephropathy in rats. The objectives. Generally, the study was conducted to determine the renoprotective property of the flavonoids of Sibuyas Tagalog bulb. The specific objectives. Number 1, to determine the percentage yield of the flavonoids. The Sibuyas Tagalog of Ilocos origin was authenticated by the National Museum Botany Division. The comminuted bulb underwent maceration, filtration, separation of the methanol from the extract, re-extraction for further purification, and lastly, separation of the solvent and the extract, thereby obtaining the extracted flavonoids. The percentage yield is 8.05%. Number 2, to identify the flavonoid extract through physical, chemical, and instrumental tests. Identification, instrumental, biological, and biochemical tests were conducted to determine the renoprotective potential. The extract is dark bloody red with ethyl acetate odor and is semi-solid. It is very soluble in water, 80 and 95% ethanol and methanol. It is soluble in chloroform and insoluble in ether and hexane. The specific gravity of the extract is 1.3429. Chemical tests to detect the presence of flavonoids were conducted and all had positive remarks. Fourier transform infrared spectroscopy, or FTIR, was used to further identify the flavonoids. The test was done at the De La Salle University, Manila, Chemistry Department. Sibuyas Tagalog extract has strong, broad phenolic functional groups as well as weak to strong aromatic carbons, characteristic common to flavonoids. Under 365 nanometers wavelength, the last peak observed had a retention time of 19.216 minutes, comparable to that of quercetin USP, which is 19.529 minutes under the same wavelength. Number 3, to identify the dose levels of the flavonoid extract, which exhibits the greatest renoprotective potential. And lastly, to compare the flavonoid extract with that of the positive control aminoguanidine. All animal experiments were performed with prior approval under IACUC, under Dr. Cynthia Ochona. All biochemical and histopathological tests were performed with prior approval of a veterinary doctor and pathologist, Dr. Mayru Libet Javier and Dr. Maria Suzanat Lola. 15 male Wistar rats weighing 250 to 400 grams were used, and they were equally divided into 5 groups, and they were acclimatized for 1 week before induction. Group 1 served as the negative control, Group 2 positive control, Groups 3, 4, and 5 are experimental groups with 100, 300, and 500 milligrams per kilogram doses respectively. The treatment lasted for 77 days. Streptozotocin was induced intraperitoneally with a dose of 60 milligrams per kilogram. Aminoguanidine, used as positive control, was administered via oral gavage with a dose of 150 milligrams per kilogram. All rats are weighed on a weekly basis prior to the computation of the volume administered to them. In biological and biochemical tests, urine collection, blood glucose test, cervical dislocation, intracardiac blood collection, isolation of kidneys, and fixation of kidneys and 10% buffered formalin were performed. Statistical analysis was performed through one-way ANOVA, followed by Danet's procedure. The result was considered statistically significant if the p-value is less than 0.05. Body weight, blood glucose, urine albumin, serum and urine creatinine, and urea nitrogen were all found significant. Only group 1 showed a decrease in the body weight, while the others increased. Groups 3, 4, and 5 were comparable to that of group 2. Group 2 had a significant decrease in the blood glucose level, and only group 4 showed no significant difference with that of group 2. The diabetic rats have high urine albumin and low in the serum, indicative of diabetic nephropathy. Group 4 exhibited the highest in serum albumin and lowest in the urine. For the urinary albumin, groups 4 and 5 showed no significant difference with that of group 2. And for the serum albumin, groups 3 and 5 showed no significant difference with that of group 2. Group 4 exhibited the lowest level in serum creatinine and highest in the urine. For the urinary creatinine, groups 4 and 5 showed no significant difference with that of group 2. And in the serum, groups 3 and 5 showed no significant difference with that of group 2. Group 4 showed the highest in urine urea nitrogen and lowest in the blood. For the urine urea nitrogen, group 4 showed no significant difference with that of group 2, and in the blood, groups 3 and 4 showed no significant difference with that of group 2. For the histopathological studies, for the negative and positive control, interstitial bleeding was observed in 1A2C, tubular hypertrophy in 1A2A, nodal diabetic glomerulosclerosis, and reduced hydrostatic pressure were observed in 1A2C, loss of tubular details in 1A and 2B. For the experimental groups, interstitial bleeding was observed in 3C and 5A, tubular hypertrophy in 3B, 4A, and 5ABC, nodal diabetic glomerulosclerosis in 5B and C, reduced hydrostatic pressure in 3ABC, 4B, and 5AC, hypercellularity in 3ABC, 4B, and 5A. And lastly, loss of tubular details in 3A, 4C, and 5A. Based on the data obtained, the researchers have concluded that the flavonoid extract obtained from Sibuyas Tagalog bulb with the dose of 300 milligrams per kilogram exhibited the greatest renoprotective property on streptozotocin-induced diabetic nephropathy in rats. The researchers recommend, number 1, to develop a better method of extraction of the flavonoids from the Sibuyas Tagalog bulb. Number 2, to perform additional HPLC tests using other standard flavonoids. Number 3, to identify the mechanism by which the flavonoids from Sibuyas Tagalog bulb exhibits renoprotection. Number 4, to perform biological tests in larger group experimental animals. And lastly, to formulate dosage form from the Sibuyas Tagalog flavonoid extract. Thank you for listening.